to start, before we actually get into number 5, I want to discuss P plus I quantity squared. Now, all this is double distribution. This too means write everything inside parentheses twice. So we have P plus QI times P plus QI. When we distribute, P times P is P squared. P times QI is plus QI. Then we go to QI times P is another plus PQI. And then QI times QI, we need parentheses here. This is QI squared. So now when we combine like terms, we have our P squared plus 2PQI plus Q squared times I squared. But remember, I squared is -1. So when we multiply that positive Q squared times the -1, we actually get negative Q squared. Now, when I'm going to break this down and use it for question number 5, we're told determine the square roots of z equals 16 minus 30i. So p squared and negative q squared, those are just the coefficients, are real numbers. So I'm going to take p squared minus q squared and put it with the real number part. So that's where I get p squared minus q squared equals 16. So now with the imaginary component, 2PQI has an I in it. That's the imaginary part. So I'm going to set that equal to the imaginary part of our answer, which is negative 30i. So here's our number z. If I want to take the square root, the 16 goes with the real part. The negative 30i goes with the imaginary part. So now I want to get Q alone. That's where I'm starting. I'm right over here, and I want to get rid of everything that's not Q. So I'm going to divide this entire thing by 2PI on both sides. So when I do that, the 2's cancel, the P's cancel, the I's cancel, and on this side I just have Q. On the opposite side, I have negative 30 divide 2, which is negative 15. The i's cancel, but I still have a p in the denominator. So q equals negative 15 divide p. Now, my equation over here says p squared minus q squared equals 16. So I don't want two variables. So instead of using q, I'm taking that negative 15 over p so that now I'm only calculating with one variable. Because we can always solve an equation. It might be hard, but we can always solve an equation with one variable. But it's really hard to solve an equation with two. So now I'm just going to go through and clean this up a little bit. So I've got my p squared. That doesn't change. Minus, because there's a minus right there. But then negative 15 squared is actually positive 225. And that p is also squared, so it's over p squared. And this whole thing is still equal to 16. Now, my biggest problem with what I'm working with is I've got this p squared in the denominator, and that's just ugly. I don't want that p squared there. So I want to multiply this entire equation by p squared to make that ugly denominator go away. So that's my goal, is I don't want to deal with the dividing by a p squared. So I'm just going to distribute this through to clean this up. So p squared times p squared. The one detail I want you to remember here is when we multiply, if the bases are the same, which they are, both have a p for the base, we actually add the exponents. So 2 plus 2 is 4. So we have p to the fourth. Now, when we multiply, we've still got the negative there. P squared over p squared cancel each other out. That's like saying 1, and 1 times 225 is just 225. Equals, and this part, somebody might make a mistake if you're not meticulous. This p squared distributes everywhere. So we're multiplying it by the 16 as well, and that's where we get 16p squared. Now, in order to factor this trinomial, I need everything on the same side equal to 0. So I'm going to take my p to the fourth. I'm going to bring over that 16p squared. So I subtract it from both sides, 16p squared, minus 225, and set it equal to 0. Now I can factor this trinomial. So I open a parenthesis. The square root of p to the fourth is actually p squared. So I'm going to say p squared, and then look at the negative 225. Since that's a negative, I know that the signs in my parentheses are different. I have a plus, and then I have p squared with a minus as well. So now I just have to think about two numbers that multiply together to get 225. But when you add them together, you get 16. So that 25 is kind of a hint because when I do anything with 25s, I get quarters at the end, right? So 3/4 is 75. 9/4 is actually $2.25. So the bigger number is the negative number. So I put the 25 with the negative, and that leaves the 9 for the positive. Now, when I calculate, only one side is actually going to give me real numbers. So that p squared minus 25 is going to give me real results. The p squared plus 9 is going to give me imaginary results. So I know I want my answers to be real. So p plus the square root of 25 is 5 times p minus 5 equals 0. So if you think inside opposite, the opposite of positive 5 is negative 5. So p actually equals negative 5. The opposite of negative 5 is positive 5. So p could also equal 5. So there's my two values of p. Now I need to go substitute and find the values for q. So here, what I'm really doing is like creating ordered pairs when we solve a system of equations. If p equals negative 5, what is q? So q equals negative 15 divided by p, which in this case is negative 5. A negative divided by a negative is a positive. So therefore, q in this case equals positive 3. Now, when p equals 5, we've still got the equation q equals negative 15 divide p. But in this case, p is positive 5. So q equals, There's only one negative, so this does remain negative, and 15 divided 5 is negative 15 divided 5 is negative 3. So these are treated as an ordered pair, right? A plus BI, P plus QI, your X coordinate, your Y coordinate. They all kind of go along the same theme. So if P is 5, then Q is negative 3. So now we can go down and actually write our roots. So for the first root, the square root of z equals negative 5 plus 3i. The second square root of z is positive 5 minus 3i. And that's how we calculate the complex square roots for question number